about endochondral ossification, which is the process of replacing cartilage with bone. This process begins about 9 weeks into pregnancy and continues into childhood. Ossification begins when the chondrocytes in the center of the hyaline cartilage model become larger and the surrounding cartilage matrix becomes calcified. These chondrocytes undergo programmed death, leaving behind cavities within the cartilage matrix. The perichondrium of the cartilage model becomes transformed into the periosteum as an osteogenic layer forms. The periosteum produces a thin collar of bone around the shaft of the cartilage model. Blood vessels grow around the edge of the cartilage. Cells change to osteoblasts, building bone outwards, or oppositional growth, to increase surface area, and becomes compact bone. Blood vessels then enter the cartilage, creating the primary ossification center, bringing fibroblasts that become osteoblasts, and creating the spongy bone. As osteogenesis continues in the primary ossification center, a cavity results as the bone is remodeled. This central cavity is called the marrow cavity or medullary cavity. Further growth involves an increase in both the length and diameter of the bone. The flared portion between the epiphysis and the diaphysis is called the metaphysis. Growth in the length of the bone occurs in the epiphysis and a piece of cartilage called the epiphyseal plate, or the growth. The secondary ossification center appears in the epiphyses in a manner similar to that described for the primary ossification. Ossification proceeds. The epiphyses become filled with spongy bone, and only a thin piece of hyaline cartilage remains on the articular surface as articular cartilage. A thin plate of cartilage, the epiphyseal plate, now separate the bone of the epiphyses from that of the diaphysis. These left by the dead chondrocytes are invaded by blood vessels that bring osteoprogenitor cells with them. Bone is produced on the surface of the calcified cartilage, and it undergoes resorption. The last step, the bone increases in length as the process continues to happen. The diameter of the bone is also increasing by oppositional growth. Osteoblasts in the cellular layer of the periosteum add success layers of bone called circumferential lamellae. At the same time, osteoclasts on the interior surface resorb bone and widen the marrow cavity. The final result is an increase in both the diameter and marrow cavity of the bone. This process continues to happen in your bones until you hit puberty and you stop growing.